Oh, that's not it. That's not the one where.
No, this one here in the black book there.
Parabolas. As this video is playing, you should be gluing in your tab in page 105. Half of yesterday's benchmark covered parabolas, covered quadratic functions, which is the topic that we're going to be covering today, starting today. And I told you guys we're going to be going over this well into maybe a week after spring break. So it's like a 3-week thing, covering all of the graphs. Now, a parabola, that U shape, whenever you're talking a ball, possible quadratic function. You're talking or throwing an object. Will go up and will go down. What object or what? The actual U shape, not the upside down U. What is something that would create that can go up and down and it just keeps going this way? Not a basketball. What's up? Not a soccer ball. If you pick a soccer ball, it's going to go up and then back down. So it goes in this type of motion. Look at the mouse. It gives you this type of motion. It doesn't have to be a ball. Y'all keep guessing balls. It doesn't. As if any object, what? If you look at that water shooting up, it's going up and then coming back down. It's still giving you a hill. I'm talking about something that gives you a U. You've used this type of motion before. There you go, a swing. A swing goes back and forth. Now that type of example is not included here, but think about it. A swing, you go back and forth, back and forth. It creates a U shape. Okay, I'm gonna skip to the end of this video because this is just 3 minutes of nonsense. I don't, no y'all don't. Jason, don't even. Now that you've seen the trajectory of all of these objects, think about it. Do you think that he would catch the ball or not? And I'm actually going to give extra credit on the last test. So I'm going to go down the list. I'm going to pause this. All right. So most people think that he's going to jump and catch it. But he misses it. Now, think about how long, let's say, for example, that ball was in the air for 4 seconds. 4 seconds. Now you throw the ball up, but then eventually it must come down, correct. You can throw the ball up, but then it must come down. Think about when it gets to, okay, it goes up and must come down. That means that there has to be a what? That means there has to be a high point. There has to be a highest point. Let me fill it solid. There you go. There has to be a highest point. If there's a highest point, that means this is the middle of the path. Now, since it's in the middle, that means both sides of this parabola of the trajectory of the path of the ball have to be what? They have to be the same. So the distance between the kid and the middle has to be the same distance. Let me copy this, control copy. Ooh, not that. Undo. Okay. Let me grab that, trace over it. That means it has to be the same as the other side as well. And notice how it goes over. That means the ball's not going to get to this point again until we get over here. That's why it went over this guy. Both sides have to, it has to be in the air. It has to go up the same amount of time as it goes down. Up, it's going up 2 seconds, coming down 2 seconds. Both sides are equal. It after that height, that peak. Okay. Let me go into now. Up until today, we've been going over just linear equations. Everything's been about straight lines. So let's go over the differences that you notice in the equations for a linear and a quadratic parent function. What does linear have that quadratic doesn't? It, as far as the shape, yes, it is a straight line, but we're talking about the equation. Yes, M represents the slope. M represents the slope. Now, what is the slope of the line? How do you find the slope? You're trying to use what? Rise over run. So let's say this graph represents the amount that you earn every hour. So I'm going to put a $sign right here, and I'm going to write the word hours. I'm just going to put HRS here. If I'm giving you $8 an hour, you're going to earn $8 every hour, $8 every hour, $8 every hour, $8 every hour. It is a constant. The rate is the same. Slope, you can achieve a straight line because slope means that it's going to go at a constant rate. Constant. You're going to increase the same every single time. You have the same rate. That's how you achieve that straight line, because you're earning the same amount every time. You're not earning $8 an hour and then $10 the next, and then $12 the next, and then $14 the next hour. No, it is the same amount every single time. Okay. What else does that equation have that the other doesn't? B represents the y-intercept. What is the y-intercept on a graph? Where it crosses the y-axis. Now look at that U shape. Look at the parabola. Does it cross the y-axis? Yes, it does. It crosses the y-axis right here. This is my y-axis. It's crossing over that y-axis. So they both have y-intercept. Even though it's not included into this equation, they both can have y-intercepts, but that is the biggest difference. Now, what did I tell you whenever we were factoring? What did I tell you made a quadratic function? The squared. When you have a polynomial, it doesn't matter if it's a binomial or a trinomial. If the highest exponent in the whole equation is a squared, that's what makes it a quadratic function. That's what makes that U shape. Now let's look at the values. Let's look at the table. That way you can get a little bit more visual. If you're increasing it at a constant rate, that means you're earning the same amount every single time. So how do I go from a -2 to a -1? +1. What about a -1 to 0? +1. And 0 to 1? +1. 1 to 2? +1. So we're increasing the same amount every single time the first time we add all of those. Notice this x, there's no exponent on it. X to the power of 1. This is what creates our straight line, because the first time around, you're increasing the same amount every single time. But here with our parabolas, with our quadratic, you have that x squared. Let me show you why. To get from 4 to 1, what do we do? Minus 3. To get from 1 to 0, 0 to 1, and then 1 to 4, plus 3. That's the first round. What happens when we try to find the difference in the second round? How do you get from -3 to 1? How do you get from -1 to 1? And 1 to 3? We're adding the same constant rate, but to the second power, Now, the parent function is y is equal to x squared. They could interchange that y with what? F of x. It can easily be switched with f of x. They can present it as f of x equals x squared, meaning the same exact thing. Now, to achieve that, you take your x value and square it. So my first x value is -2. If I square it, what do I get? 4. -2 times -2, 4. If I square that -1, -1 times -1, 1. Two negatives make a positive. What about 0? 0 times 0, 0. What about 1? 1 times 1, 1. 2 times 2, 4. You're squaring your x value every time. That's why you see that increase, that decrease, then increase, or increase and decrease. Creates that U shape. That U shape is called a, once again, parabola, not a parabola. I'm always going to get somebody tells me a parabola. No, parabola. A parabola gives you that U shape. That's the name of the shape of a quadratic function.
Parabola.
The name of the shape of the quadratic function. A parabola is the name of this shape. Will you keep asking the same question?
It's like,
A straight line,
what's the difference between saying that? What someone can say that? I think like,
parabola.
what does the other one mean?
No, it's just not pronounced correctly. Now, you achieve a straight line by increasing or decreasing, growing or shrinking, increasing or decreasing at a steady rate. You're going to earn $8 an hour or you're going to lose $8 every hour. Same rate. Now, in a word problem, they'll use for a quadratic function, they'll use the word projectile motion, an object in motion, throwing or dropping an object. Projectile motion, okay? Now, those are just characteristics. This is just trying to compare the differences between quadratic and linear. And we still have one more graph to learn after we're done with this unit, okay? So let me move on to my next tab if it'll let me. There we go. There it is. Characteristics. This is the main part of the lesson. Learning all of the characteristics of a quadratic function. Now, some of these characteristics transfer over from linear equations. Some of these you should already know regardless if you've seen this type of function or not. Let's look at this big box right here, okay? This big box has two arrows pointing right here. What are these 2 points called? These 2 points are where my parabola is doing what? Crossing what? The x-axis. So these 2 points are called your, Ada, I really hope you end up gluing that in the correct spot and you are not following along with the rest of us. These are called your x-intercept. In outside of the box. The reason I want you to write it outside of the box is because there are 3 other names on the STAR test that they use for your x-intercept. You should know some of them. Okay, I guess we don't, which explains the scores. Zeros. Zeros is the most popular word that you're going to see used on the STAR test, especially with quadratics, so I would highlight it. They'll ask you, what are the zeros of the function? And there's one more that we used last semester, not super popular with this unit. Starts with S. Nope, slope is strictly used with linear equations because slope is always constant. You cannot use slope with any other type of function. Okay. Solutions. Another point on this graph that you should be able to identify, regardless if you've seen this or not, if you've seen the U or not, is which one? The y-intercept, where it crosses the y-axis. Once again, I'm going to write it on the outside, y-intercept. What's another word for the y-intercept?
Rate of change.
Rate of change is slope. B is only linear. They don't use B for quadratic functions. Starting point. Starting point. Now, if I told you to identify this ordered pair, to tell me what this ordered pair is, what would you give me? What is the ordered pair for this point? 0, -3. So any y-intercept gives you 0 first and then your y value. Versus if it's an x-intercept, what would it be? Your x value, then 0. For every x-intercept, you're going to have an x value and 0. For a y-intercept is 0 and your y value. Okay. Now, new word, you may have seen it after doing your, after going through IXL and everything. Now, when you're swinging or when you're throwing a ball, I said that there's going to be a high point and there's going to be a low point. If I told you the highest amount of points that you can make on the STAR test is 100, you would also call that your, starts with an M, maximum. Maximum. Maximum refers to the highest point on a parabola. But if we're talking about low, lowest point, it would be correct minimum. Minimum is referring to the lowest point on the parabola. Lowest point. Now, both of those are a subcategory of the word vertex. Vertex. The vertex is either considered the lowest, the highest, or the lowest point on your parabola. This is your vertex right here. It's the lowest point on this parabola, but it can be the highest point on other parabolas. A lot of people tend to forget where the vertex is located. Look at the letter V. The letter V has a what? A low point. If you flip it upside down, it has a high point. Use that to your advantage. Use that to remember what the vertex is and where it's located. Now, the vertex is located where on my parabola? In the bottom, but it's also located. Think about the distance. In the, what? It's in the middle, correct. It's in the middle. It's in the middle. Whenever we were throwing the football, you could say that it took 2 seconds to get to the middle and another 2 seconds to get back down on the ground. Now, that is the middle. We're gonna have an imaginary line. That's why it's dotted. We're going to draw an imaginary line every time on my parabola, so we could split it into equal halves. Think back to whenever you were in kindergarten and you put paint on a piece of paper, you folded it in half. What would happen when you open it back up? What happened to both sides? It would be the same. So what word did they use for that? Say it again. Symmetry. Symmetry. Because symmetry means that both sides are going to be identical. Both sides are identical. And now if we split it in half, if we draw a line down the middle, we would call that our line of symmetry, okay? Our line of symmetry. Now, obviously it's not going to be that phrase is not going to be that easy on the STAR test. They actually use the word axis of symmetry. Think about it. If we had a new student and they didn't know what the x-axis was, how would you describe it?
It's where the line crosses
The x-axis, just the x-axis alone. Describe the x-axis. How would y'all describe the x-axis? Those of you that have your heads down, I need you to get them up right now. Up, higher, higher, sit up, sit up. How would you describe the x-axis if I didn't know what it was? What would you say? A horizontal line, line. Axis is just another word for a line. The X line. X-axis, the X line, the line of X. So line of symmetry, axis of symmetry, okay? All right, let's go through these vocabulary words. What's the name of the shape again? Parabola. The point that could be either the minimum or the maximum is called the vertex. Remember, it's either the highest or the lowest. But the lowest specifically is what? Minimum. The highest is maximum. Axis is another word for what? Line. Axis is the same as line. Line of symmetry. Splits it into two equal halves. Now, what point is located where the parabola crosses the x-axis? X-intercept. But just so we go back over and over and over again, what are three other words for the x-intercept? Roots, zeros, and solutions. And which one are we most likely going to see 90% of the time? Zeros. All right. What point is located where the parabola crosses the y-axis? Y-intercept, which is also known as the correct starting point. Now, remember, when they use the word starting point, it's usually used or referred to in a word problem, in a real world problem, okay? Flip it over. Now it says locate the following points, locate the points of the following parabolas. Now, remember, I told you guys that factoring tied into quadratics. This is where I get to show you how it ties into quadratics. If we were factoring this trinomial, where's the first place that I need to look at? In front of my squared term, in front of the squared term, but I don't see a number. So how do I continue factoring this? You do not need to put a 1. Correct. You go straight to your diamond, putting the last number at the top, -5, and putting the middle number in the bottom. So what two numbers multiply to get -5, add to get -4? -5 and 1. Once I factor that, once I solve my diamond, I put those into parentheses in my binomials, x minus 5, x plus 1 for +1. Now, another thing that we're going to add in a couple of weeks, I'm just going to use this to show you where these numbers are coming from. But the next step will be to set these equal to 0. So x minus 5 equals 0. Split this one up, x plus 1 equals 0, and solve for x. It's a one-step equation. How do I move the 5 back over? plus 5. Okay, so we get x equals 5. And how do I move the 1 over? Minus 1. So x equals -1. Okay, so we factor everything. Now, can someone tell me what the left x-intercept is on the parabola? -1, 0. -1, -1. See that? What about the one on the right? Positive 5, 0. 5, 0, x equals 5. We'll move. My bad. Here it is. -1 is one of my factors. Positive 5, after I'm done solving, is the other factor. Solving or factoring all of these, all it does is help us find what my x-intercepts are. So sometimes you're going to be given a graph, so it's as easy as looking on that graph and finding your x-intercepts. But sometimes all they do is give you that equation, so you have to factor and solve to find your zeros. Okay, so let's go ahead and identify these points. Your roots, also known as your zeros. I'm going to use zeros because that's the more popular one. Those are both describing what? Your what? X-intercept, x-intercept. So give me the ordered pair on the left. -1, 0. What about the one on the right? 5, 0. If it's an x-intercept, it should be something 0. You can just look at the graph and tell me what those numbers are. Y-intercept, where it crosses the y-axis. What is the point where it crosses the y-axis? 0, -3. 0, -3. Now, we said the vertex could either be considered a maximum or minimum. Does this go up high or does it go down low? It goes down low. So my vertex is going to be what type of vertex? A minimum. But what is the ordered pair for that vertex? What's the point? 2, -5. 2, -5. That is the ordered pair. And what did we say was the axis? The axis is just a type of, it's just another line. So I'm going to write the word line, line of symmetry. So you yourself, I want you to draw with your highlighter, draw a line of symmetry. Draw a line that's going to split that parabola in half. And what do you notice? It goes through the what? It goes through the middle, but what else is in the middle? Not the x-axis. The vertex is in the middle as well. The vertex is in the middle as well. Now, oh, we didn't write it in the front. Your line of symmetry is specifically what type of line? Even though it's imaginary, it's what kind of line? It's straight and it's, heard somebody over here. Vertical. What did we learn about vertical lines? What acronym did we use for them? BUX. Now the U in BUX stood for what? Well, what about the X? Not x-intercept, x equals. So because your axis of symmetry is always going to be a vertical line, it's always going to be x equals. And it's going through what? X equals 2. The line also, Angel pointed out, is that the line also goes through what? The vertex, right? So if you look at your vertex, the x value is 2. The line of symmetry, x equals 2. So those should always match up. Your line of symmetry will always be the x value of the vertex. If you can't figure that out, you can draw it on your graph, draw the line of symmetry, but it will always be x equals to the x value because that line of symmetry goes straight through that vertex. Let's look at the next one. X, we're not actually going to take the time to go through all of the factoring, but this one will give you x plus 4 and x plus 4. It gave you the same exact binomial. So when I solve, I'm still going to get the same exact answer. X plus 4 equals 0. How do I finish solving that? Minus 4. X equals negative 4. And what do you notice? My 0 or my root is what? And there's only how many? How many times does it touch or cross the x-axis? 1 time. So that means there's only one root. There's only 1 0. And that is possible. It is possible to only have one x-intercept. So give me the ordered pair for that x-intercept. Negative 4, 0. Now, can you see the y-intercept? I can't see the y-intercept on the graph. You will be able to on the assignment. So, but we do know y-intercepts are 0 with some type of value. Now, let me show you something. If you are given an equation, hold on, because I want you to write this down. This little thing needs to move away. There we go. If you are given an equation, this last number right here, the C, will always represent your y-intercept. Oops. I'm just going to underline it. This number here represents your y-intercept. Write that on your little half sheet. That last number in your trinomial represents the y-intercept. The number that's by itself in your trinomial represents the y-intercept. The number that's by itself in your trinomial represents the y-intercept, and it is on the half sheet, not on the front of the foldable. C represents the y-intercept. Yes. Got it? So even though I can't see it on the graph, I do have an equation. So what is the y-intercept? 16. Even though I can't see it on the graph, I can see it on the equation. It's 16. All right, now the vertex we said could either be the maximum or minimum. In this example, it's the minimum, because it's a low point. What is the point of that vertex? Negative 4, 0. Negative 4, 0. Yes, it is okay that the root and the vertex are the same. That is okay. Draw your line that splits it in half. Draw your axis of symmetry. And it crosses through where? It crosses through the vertex. So what do we get? X equals what? Negative 4. X equals the X value. The X value of the vertex should always match up with the axis of symmetry. Okay? Flip it over or turn the page or whatever. Number 3, why do you think I didn't give you an equation? What's the whole point of having that equation? It helps you find the what? It helps you find the, it helps you find whatever I'm writing, the roots, the zeros, the x-intercepts. When you solve, when you factor, that helps you find the zeros, the roots, the x-intercept. But if you look at this parabola, is there an x-intercept? No, because it's not touching the x-axis. Everybody see that? If it doesn't cross or if it doesn't touch the x-axis, there isn't an x-intercept. So this would be none. Okay. Now, once again, I still can't see the y-intercept, so I'm just going to do 0 question mark. I don't know what it is, but can I see the vertex? Can I see the vertex? Yes or no? Yes. And what kind of point do we have on the vertex? A maximum or minimum? Minimum. We have a low point. What is that low point? 4, 2. Okay. Use your highlighter. Go ahead and split that in half. When we split it in half, what are we creating? The what of symmetry? Or the axis, the line or the axis. And it's going through what number? So it's x equals. Does it match with my vertex? Yes. Last one. Everybody got this one? What part of that equation tells you that it flipped it upside down? The negative. The negative is what flipped this upside down. Negative. I'm just going to write negative. Negative flips my parabola upside down. Now I'm just going to factor out, I'm going to factor this part out for you, x squared negative times x squared plus 6x plus 9. When you factor it out, it gives you x plus 3, x plus 3, which is the same exact binomial. So if I solve it, if I take x plus 3, set it equal to 0, how do I move the 3 over? Minus 3. And both of those, regardless of how I solve both of those, they will both give you, both binomials will give you x equals 3. Why is that? Because there's only what? One root. There's only 1 0. Okay. So what is my 0? What is my x-intercept? -3, 0. Once again, we have one with only 1 0. It could, like the example above, have no zeros, or it could have 2 zeros, like in the other examples. Can we see the y-intercept here? Not on the graph, but can we find it on the equation? What is my y-intercept? -9, -9. So it would be what? 0, -9. Can I see the vertex? Yes. Is it a high or a low? Which makes it a maximum. And what is the ordered pair for it? And I know for a fact that my axis of symmetry is going to go through it. So it should be what? X equals -3. X equals -3. All right. So I've already written on the board where you're supposed to glue all of the stuff.